All right, so before I just give you one of these and you have to just sit down and fill it all out by yourself, we're going to fill this one out together. We're going to start with the radians. So we have all our degree measures in here, and these little blanks right here are like the fraction bars for your radians. Okay, so let's talk about your how to think through this in terms of fractions. You have to have some fractional thinking here. So the 0 degrees is the same as 0 radians. Then we know that 180 degrees is how many radians? Pi. And then all the way around is 2 pi, right? Which means that 90 is what? Pi over 2. So if we think in terms of halves, I'm at 0. I have 1 pi over 2. This is 2 pi over 2, which is pi, which makes this right here what? 3 pi over 2. And then that makes this 4 pi over 2. That's where 2 pi comes from, right? All right, so then let's start with 60 here. So 60 is a third of 180, which means for the radians, 60 is what? Pi over 3. Okay, so this is pi over 3. So I'm at 0. 60 degrees is 1 pi over 3. Another 60 degrees gets me to 120, so that is 2 pi over 3. Then another 60 gets me to 180. That's 3 pi over 3, which is pi. Another 60 would get me to 240, which would be 4 pi over 3. Another 60 gets me to 300. That makes that 5 pi over 3. Another 60 gets me here, which is 6 pi over 3, which is 2 pi, right? So you notice how all the pi third angles are all the ones that are closest to the y-axis, right? We got some symmetry going on there that we did with our little flipping of our triangles. Now let's talk about 45. 45 is half of 90, so instead of pi halves, this would be what? Pi fourths. So this is 1 pi over 4. This is 2 pi over 4, which is pi halves. That makes this 3 pi over 4. 4 pi over 4 is pi. That makes this 5 pi over 4. Then this becomes 6 pi over 4, which is 3 pi halves. Then this is 7 pi over 4. And then 8 pi over 4 is 2 pi. 30 degrees is half of 60. Well, half of pi thirds is pi sixths. This is 1 pi over 6. 2 pi over 6, which is pi thirds. 3 pi over 6, which is pi over 2. 4 pi over 6, which reduces to 2 pi thirds. That makes this 5 pi over 6. Another 30 gets me to 6 pi over 6, which is pi. Another 30 is 7 pi over 6. Then 8 pi over 6, which is pi thirds. 9 pi over 6, which is 3 pi halves. 10 pi over 6, which is 5 pi thirds. Then 11 pi over 6, which doesn't reduce. And then 12 pi over 6, which is 2 pi. Okay? And all the pi sixth over 6 angles are all close to the x-axis. The fourths are all in the middle. 2, 3, 4, 6, right? If you can get the first quadrant down, you can get the rest of this down. It'll be a piece of cake. Look at just the patterns with the radians. Would you agree that once radians you're more comfortable with them, you can see patterns in there that you don't necessarily see in the angle and the degree measures, right? With the degree measures, you got to know the numbers and do some other adding and subtracting and whatnot. I should be able to give you an angle in radians that you can tell me which quadrant you're in. If you can think about 2 pi and pi, you should be able to get that down. If I tell you it's 5 pi over 6, well, if you can think in terms of sixths, the 6 pi over 6 is pi, so 5 pi over 6, you're not quite there yet, right? So you're in the second quadrant. Or if I give you 4 pi thirds, well, 3 pi thirds is here, so another pi thirds gets me into the third quadrant, things like that. And 11 pi over 6, well, that's almost 12 pi over 6, so I'm in the fourth quadrant and almost there. Even if, you should be able to tell me what the reference angle is that goes with it. If it's a sixth, it's the pi sixth reference angle. If it's a fourth, it's pi fourths. If it's a third, it's pi thirds. Okay, where if it's an angle, if it's a degree measure, you're going to have to do some other subtraction. Okay, everybody okay with the angle measures and how to think through those? So let's talk about the ordered pairs. The quadrantals are pretty easy here. We got 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. And there's lots of patterns in here. There's lots of different ways that you could make it make sense to you. I'm not saying you have to do it one way or the other. I just want to make sure everybody sees it, because not everybody always sees the patterns, and it's not always that easy for everybody. Every other ordered pair that's not on a quadrantal angle is all over 2. Okay, so that shouldn't even be a question. It's something over 2. If you have like a picture of the first quadrant in your mind, and you look at the x values here, all the numerators are 1, 2, 3. And then the y's are 1, 2, 3. They all have square roots on them, but the square root of 1 is 1, so we don't actually put it. And we put square roots on everything that's not a 1, and there are your ordered pairs. Okay? So that's one way to do it when you're looking at it as a whole. If you just need an individual one, I will kind of help you with that here in just a second. All right, so then we reflect that. All those points get reflected in the y-axis. Well, when you reflect in the y-axis, all you do is change the sign on x. So these the number values are the same. We just change the sign on the x value. So since x was 1, 2, 3 over here, it is 1, 2, 3 over here, 1, 2, 3 on the y back up. Put all your little square roots on there. Negatives on the x's. Then these get reflected down here, and which means that your y values start with 1, 2, 3, 1, 2, 3. Square roots, you should know what quadrant is what here. We're in the third quadrant, so it is negative, negative. Then, what would this look like? What goes right here? 3 or a 1? 3, right? The 1s are the y values down here. And then we are in the fourth quadrant here, which means it is positive, negative. And it looks like that. We've written the same numbers over and over again, just in a different spot and with a different sign, right? And so if you can make sense of the first quadrant, you should be able to reason through the rest of what you have. Okay? Everybody okay with that? Any questions at all? All right, so one of the questions that came up was this whole positive, negative in the different quadrants. What does that even mean? Okay, and that's one of the things that was on the notes yesterday, so I'm going to kind of re-explain it here, and hopefully it will all make sense to you. So what we know is all of these ordered pairs are cosine theta, sine theta, right? And then we know that tangent theta is sine theta over cosine theta, and we'll look at that again here in just a second too. So what you've known forever, since before you were in Algebra 1, and remember, I don't say things like that to say you're stupid so you should know this. I'm telling you that it's the same thing. I don't want you to think of it like it's something brand new and different. It's the same stuff. Forever you have known that in the first quadrant you have positive, positive. X is positive, y is positive. Quadrant 2, x is negative, y is positive. Quadrant 3 is negative, negative. Quadrant 4 is positive, negative, right? All that makes sense to you? Okay, so what that means then when we talk about the trig functions and whether they're positive or negative in those quadrants, we're talking about the angles and what quadrant does the angle end in? Where's the terminal side? So like 7 pi 6 is in the third quadrant, right? Which means that tells me something about the sine, cosine, and tangent value, whether it's positive or negative, whether I know what the sign is or not. So what this means is positive, positive. Cosine value is positive. Your sine value is positive because the cosine and the sine are attached to an x and y value. Since when you do tangent, it's positive over positive, that means that tangent's positive also, so they are all positive in the first quadrant. Does that make sense to you? In the second quadrant, your x value is always negative, always has been, always will be. So your cosine value is negative. Your sine value is positive. Because tangent is sine over cosine, that means I'm going to put positive over negative, which means in the end tangent's negative also. So your cosine and your tangent are negative, which means sine and its reciprocal are the only positives in the second quadrant. You with me on that? Cosine and sine are both negative in the third quadrant. Well, when you put negative over negative to get tangent, you get that the tangent is positive and it's reciprocal. Fourth quadrant, cosine is positive, sine is negative because it's your y value. When you do tangent, it's negative over positive, so tangent is negative also. So cosine is the only positive in that quadrant. And that's where that all students take calculus come from. It's just a little mnemonic so that you can remember what's what there. Okay? Does that make sense to you? And so if I know that my reference angle is pi sixths, right? And the cosine of pi sixths is square root of 3 over 2. Yes? So if I know that, and my reference angle is pi sixths, but I'm asking you about 7 pi sixths, well, we're in quadrant 3. In quadrant 3, is cosine positive or negative? It's negative. So it's negative square root of 3 over 2. Same value, but it's negative square root, which I can just look at this and pull that off. Yes, but if you don't have that in front of you, you have to have a way to reason around it. Does that help a little bit? Does that clear up maybe some things? And I'm going to do one of the same questions I did. I'm going to re-explain it on the homework as well in just a second. Okay, are we all good so far? All right. Now I'm going to show you one other thing before I give you something different, and then we're going to talk about the hand trick that's going to help you with this as well. So this, I know this is a little overwhelming. I don't want this to freak you out because this isn't anything you're going to have to deal with much. This just explains why these things are what they are and where they all come from. So I'm going to explain how we get tangent again, because that was a request from last period as well, and just to make sure that we're all clear on this. Do we see the similar triangles with the red and the blue? Okay, we all agree that they're similar triangles. So I can set up a proportional relationship. The leg of this blue triangle over the other leg will be sine theta over cosine theta. That's equal to, well, the leg that corresponds to sine is this one right here. That's the length, that's the tangent value. This leg that corresponds to the cosine value is this leg down here, which is now the radius of that circle, so it's over 1. Therefore, sine theta over cosine theta is tangent theta. Does that make sense to you? Does that help? Do you have a question? Ask me a question if you have a question. It took a while to get any questions or any comments out of anybody last period, but then people finally started opening up. If I lost you somewhere, tell me, because you're probably not the only one that's lost. Let's look at cotangent. You see this segment that's up there? That's the length of cotangent, okay? Well, why? Let's figure out why. Do you see the green triangle there? You see I have like a green, a red, and a blue, basically. So we know the red and the blue, we all agree those are similar. Is the green triangle similar to the red and the blue triangle? Yes, with a question mark on it. So yes or no? You gotta be confident. Yes. By how? How do you know? The angles are congruent, right? Well, we know they got right angles, like we're good, right? Theta, is theta congruent to this angle right here? No, not necessarily. I mean, it's possible, but no, that's not what's happening here. Theta, well, tell me about these two angles and these two triangles. What do they have to add to give me? 90, because the acute angles in a right triangle are complementary, right? So theta is congruent to this angle over here, right? So that tells you where your corresponding sides are. That's an important thing to be able to. So this side that's across from theta corresponds to this side, that kind of thing, all right? So when we look at cotangent, well, we know that cotangent, we already know part of this, but it kind of proves what's happening, or it could be figured out if you didn't know. We know that cotangent is the reciprocal of tangent. So that's the sine of theta. No, it's not. It's the cosine of theta over the sine theta. I was writing it backwards. We all agree with that? Like that's cotangent? So if I looked at just the blue triangle and I did it with the blue and the red, then I'd have cosine theta over sine theta equals 1 over the tangent of theta. Well, yeah, that's what cotangent is. But how do we get that segment? Well, when you look at this green triangle, we did cosine. That side length is the one that's attached to the theta in the 90, right? So in the green triangle, that corresponds to this cotangent segment right here over the sine theta, which is the other leg, right? So I did cosine over sine, leg over leg. So I do this leg over this leg. What's the length of that leg? 1, because it's the radius. Okay? So that's why the triangles have to get extended so you can make, right now, the blue one, the ones that are in the unit circle, the hypotenuse is 1. If we extend things so that we get similar triangles and we can make a different side 1, that's where these other proportions come from. Because we would, how do you know that specific? No, I'm with you. So I'm trying to process through how to answer that question. Because those ratios are already defined. So the fact that cosine over sine is cotangent, that part's already defined. What this is defining, and so this has like too much labeled on it. Like when we did this on the unit circle, because I know what you're asking, let me make sure I can get my explanation out correctly. If we came to this conclusion on our unit circle is we didn't have that labeled, like we didn't know that. We had it labeled as AB. And we already knew that tangent was sine over cosine. Does that make sense to you? So the fact, this doesn't necessarily define cotangent as cosine over sine. That part's already defined. If I didn't know which part I could label on here, like which side of the triangle was cotangent, that's how I would come up with that. Does that make sense to you? That's how that length is defined. The definition of cotangent being that ratio is defined in a different way. Does that help? That's a good question. Does that make sense? Because I know what you're asking. I don't know if I'm getting that out right. Okay? Because basically it's already labeled for me. It's kind of obvious that that's what it is because it's right there. But that's how I would figure it out that I know that it's for sure happening from the proportions. Okay? That's a good question. Anything else? All right. What I want you to understand is that nobody's making this stuff up. And all of this comes from similar triangles. And I told you all year long in geometry that it was not going away. And that I promise I'm not lying to you. And I know you're not going to use it in Algebra 2. And you're going to think all year in Algebra 2 I was lying, that the stuff isn't going away. I wasn't lying. It's all about to come back and hit you in the face real hard. Okay? So you get, it's all... I'll just go ahead and work that now. Let's go ahead. We're kind of on this topic. And let's, I'm going to rework number 9, because that was kind of the request from yesterday. I think that part of the issue was understanding exactly what was going on here and how to think through this. So I'm going to say it again. And hopefully, not really saying anything different, but maybe by me saying it live and in person. And if you can ask a question, that will help. Okay, so I jotted down this, which is not necessarily something you have to write down every time. For some people, once you understand it, you kind of have that picture in your head. Or just even, some people just write down like this, and that's kind of enough so they can, think about where the pieces go or whatever. Whatever works for you, and, it'll get better and better, but you have to practice as you go along. Just having that visual of what's going on. We want the cosecant of 7 pi 6. Now, the things that I jotted down are things that I would write down when I do it myself as well. Because although they're simple, you have to think through like 4 things. And once I get to the 3rd thing, I will have forgotten the first one and have to go back and rethink it. I mean, that's me. It may not be you, but that's me. So I also write it down so I don't lose you. So cosecant. First of all, it's going to be easier for you right now, especially to think in terms of sine. So you have to know cosecant is 1 over what? Is it sine or cosine? Sine. Okay. So it's 1 over sine theta. So if we can think about sine, we're good, right? Then I got to think 7 pi 6. Which quadrant am I in? The 3rd, because if I go here to here, this is 6 pi 6. This gets me to 7 pi 6, so I'm in the 3rd quadrant. Okay. The reason I need to know which quadrant I'm in is because I'm only really fully comprehending the 1st quadrant right now. And so all that changes in my 3rd quadrant is what the sine is, maybe. So is sine theta positive or negative in the 3rd quadrant? Sine theta. It's negative because this whole all students take calculus, that might be something you need to jot down at the top of your test or whatever too, or have it in your mind, whatever works for you. Tangent and cotangent are the only things that are positive in the third quadrant. So I know I'm in the third quadrant, which means my answer, the actual cosecant and sine values are negative. So I'm writing that down so I don't forget to make a negative, right? And then the other thing that I think I probably wrote right here, and I'll write it right here, but I'll write it. My reference angle is pi sixths, because that's my first quadrant angle. Does everybody understand why that reference angle is pi sixths? Because that's how much more I had to go. So if I can find the sine of pi sixths, which is my first quadrant stuff, I can figure the rest out. I've just got to make sure that I'm using all the other pieces and what changes when I get in the third quadrant. So I'm really just finding the cosecant of pi sixths and doing some adjustment. So the sine of pi sixths is what? The sine of pi sixths is 1/2. Pi 6 is right here. The sine is 1/2, right? So the sine is 1/2. That's not my answer, but that is what I need to be able to adjust to get there. I don't really want the sine. I want the cosecant. So the reciprocal of 1/2 is 2. And then not only is it reciprocal, but it also has to be negative. So my answer is -2. Does that make sense to you? So you see that you have to think through like 6 steps. There's not a whole lot of work. There's just reasoning through, this is what the reference angle part of it is, and then how do I take that and adjust it to the third quadrant? Otherwise, you have to know the entire circle and every single one of them, and there may be a couple of people where that's like the way to go, but for most of us, that's just not how our brains work, and that's okay. That's why you need those reasoning things. So let me just talk you through number 10 again. -5 pi fourths, right? So I'm starting here, I'm going to go clockwise. So 4 pi fourths gets me to pi, so another pi fourths gets me up here in the second quadrant, right? I'm looking for the tangent. Well, in the second quadrant, tangent is negative, because sine and cosecant are the only things that are positive. You with me? That's why I wrote down negative. And then my reference angle is pi fourths, so I can think in terms of the first quadrant. So I have to figure out what the tangent of pi fourths is. Well, tangent is sine over cosine, and for pi fourths, sine and cosine are the same. So I make my little fraction, and they're just going to become 1, right? Except that it has to be negative, so that's where I get the -1 from. And if you look at your big unit circle, that pink one you have, and go to -5 fourths, then you'll see that you have a -1 there. Oh, actually, it's not labeled on there. I'm sorry, because that's tangent. But if you did the sine of 7 pi sixths on your unit circle, it would be -1/2, and then we just took the reciprocal. But you're not always going to have that unit circle to refer to. So as you're doing these, if all you're doing is looking at your unit circle and pulling numbers off, you're not practicing, and then it's not going to make sense. Use it to help make sure that you agree with yourself and to double check yourself, but try and think through it on your own first. Okay? Does that make sense? Ask me questions if you got questions. No? Okay. All right, so I'm going to hand out, go ahead and, well, actually, let me hand this out. We're going to talk about another little device to remember things. Okay, so let's look at this unit circle hand trick here. You're going to have to look at my fat fingers up there to help you with this. But if you lay your hand out, palm side up, like so. So your pinky finger here is like the x-axis, your thumb would be the y-axis, and then these are your 3 special angles in the first quadrant. That makes sense to everybody so far? Okay. So we want a way to understand what our 3 sets of ordered pairs are here. The quadrantal ones are easy, but we'll get to those in just a second. We know for these 3 right here, all 3 of them are fractions over 2. So we can go ahead and just start with the over 2 part of that. Just put it on all 3 of those. That doesn't change for any of them, okay? And this time the blanks aren't really the fraction bars because there's not a space to write underneath them. But so if these, my pinky represents 0, my thumb represents pi halves, so my middle finger is pi fourths, ring finger is pi sixths, my index finger pi thirds, right? We all understand how that works. So let's say I want to know what sine and cosine are for pi 6. Well, pi 6 is my ring finger. So if I pull my ring finger back, the fingers I have on the left, there's 3 of them that are remaining and 1 on the right. So 3 in the numerator for x, 1 in the numerator for y, and it's the square root of the number of fingers you have. So then when I go to pi fourths, you're going to pull your middle finger back. So now you have 2 fingers on the left for x, 2 fingers on the right for y, and it's the square root of your number of fingers. Square root of 2 over 2, square root of 2 over 2. Pi thirds is your ring finger. When you pull that back, you have 1 finger left on the left, 3 on the right. So the x value is 1/2. The y value is the square root of 3. After we do this, and then we have a quiz, it always looks like everybody's playing air guitar while they're thinking through their quiz. It's really kind of funny just to watch all as a whole. Everybody's going, think of them. So do you understand the process there? If I want pi 6, my ring finger is pi 6. Square root of 3 over 2, 1/2. That's the way it works. Okay? And use your hand. Now let's talk about 90. Well, if I want 90, that means I'm pulling my thumb back, right? I have no fingers left on the left-hand side of my thumb. The x value is 0. I have 4 left right here. What's the square root of 4? 2. Over 2 is 1. If I pull my pinky back, I have 4 fingers on for x. That would be the square root of 4, which is 2, over 2, which is 1. And there's none left over here, and it's 0. Okay? Does that make sense? We good with that? Okay. Any questions about that? Use it. That will help you. This is one reason why you may not have to write down everything we just had on that little homework where I drew the whole thing. Maybe the angles you need there, but your fingers should help you with what these values actually are. And then, so this kind of explains it too, just in case you needed more words. Any questions about this? I think it was 90. I think this one's 90. Okay. Pink is 89. This one's 90. Yeah, sorry, I didn't write that. Practice. That's all I can tell you is practice, practice, practice. Spend 5 minutes staring at your unit circle reference. Flip those triangles on the other one. It helps you. Think about what this is. I'm not saying hours a day, but literally 5 minutes a day can help you. Practice cards. Let that help you a little bit, okay? Now, I'm going to show you something on your assignment for today before I actually give it to you. So this, up at the top, there's a little remember. So it kind of explains to you the whole cosine-sine relationship again and tangent relationship with this unit circle here. And then there's some more you have to come up with down here. Now down here, I don't just want the line segment answers here. You're going to have proportions that prove that to me. Okay, and this is what I mean by this. It gives me this picture over here, and it says sine theta is represented by blank. All right, well, this is theta. So you should know by now that which segment would represent sine theta. What would it be? Opposite. PA, right, over OP, which is just 1. So it's just the length of line segment PA, the y value on the unit circle, right? So sine theta is represented by line segment PA. You name a line segment with 2 capital letters and a line segment above it. The proof that goes along with that is that the length of PA over the length of PO is equal to the length of PA over 1, because it's 1, right? And so that's why it's this line segment. When you're talking about them as numbers, they don't have line segments above them. When you are naming them as line segments, they do. Remember, again, the geometry stuff is all coming back. Your notation is important and it matters, okay? So that proportionality is important. So you just have to have a little proportion to the side, because some of these, yeah, you can just pull it off of there and it's pretty easy. You might have to think through the secant, those just a little bit more, but I just want to see those proportions out there so you can see where your triangle is. It should be fairly simple. It won't take you that long. We good on that? On the back here, there's some reminders about special right triangles, and it even has the sine, cosine, tangent values there. They're there. You have them on a few unit circles. Yes, you can look at that and pull the measurements off, but try and think about it without looking. Use your unit circle and use this stuff as a tool to help you and to help reassure you that what you have is right, not as a crutch where you're not even thinking through it at all. So just to kind of explain this, because it might seem a little bit weird, but it's telling you to do these things like whatever the value of M is plus the value of B, you would put it in this little box here. So you have to come up with these. Try and come up with them without just looking at the top or looking on something else. See if you can figure them out. You shouldn't have to draw pictures and stuff, but maybe think through things, maybe jot something down. It shouldn't be crazy hard for you to come up with these. Those aren't that bad. But then when you find what these values are, you add the M and the B together and you put them here. You put M minus B minus A here. But when you put them in there, you may need to do some work off to the side, because it may not all fit in that little box depending on what it is. If you get something like the square root of 3 plus 1, you're going to have two terms. If I have the square root of 3 over 2 plus 1, you need to combine that together so that you have one fraction. Does that make sense to you? So if there's a fraction in there, it all needs to be in the same fraction, basically, is what I'm getting at. You may have two terms if it's not a fraction, but I don't want a bunch of fractions added together. Put it together with common denominators. They'll all be basic and simple. It's not that bad. I just don't want you to be lazy and just write it and stop. But put them together and then just read the rest of what it says. It's just having you like add the values together and whatnot. Okay? And you might need a separate sheet of paper for that. Any questions at all? Awesome. All right, so let me make sure all that stuff is glued or taped in now. You definitely want to keep it all together.